Okay, so we're going to get our first program ready to type in and run. I've loaded up JGrass, and I'm now going to go over to File, New, and you're going to see JGrass or Java listed here. Okay, I need to do this first, and it's going to create a window for me where I'm going to type in my Java programs.
Wait, don't we need to create a folder first to put this in?
Not for this, no. Yep. VS Code, you would need a folder. Okay.
Okay.
So I got it. I'm ready to type. And, I just typed 2 front slashes and it turned it yellow. Well, 2 front slashes are going to give me something called documentation, internal documentation. The computer, when it compiles, I mentioned that a while ago, is going to ignore anything that's orange. Okay, so if I want something to be orange, I want it to be documentation, I want the computer to ignore it, I'm going to type in those 2 slashes. All right, good. So far, I have everything going. I put blank lines in because I know I need some line spacing and so on. And I'm going to get ready. And every program has to start with public class. And you notice how they turn purple on my screen because they're called reserved words. They're words we can't use. Java says, I need these words. Okay. We're going to create a demo program here. So what would you like to call it? Just intro demo.
Demo is fun.
I'm going to keep it simple. Intro demo. Now, this is a word I made up. Intro demo. You notice the first letter in the first word is lowercase. And then for my second word, I have an uppercase. No spaces in there. Okay. Intro demo is now going to be the name of my program. When I save this, I have to save it as intro demo, and it'll put the .java extension on it. So I'm going to do File, Save As. Because I called it intro demo up there, I need to call it exactly the same thing here. Intro demo, and you notice it says file type Java. So I get ready and I save that. So right now in memory, I have intro demo.java. Now, what comes next? It's called a bracket or a brace. Every time I type one brace, I'm going to type another brace. And in this case, I'm going to refer to them as left braces and right braces. Everything I do in intro demo is between these 2 braces. Inside of intro demo, I'm going to indent a little bit, and I'm going to put this line that you are going to type 6,000 times. Public, static, void, main, string, square bracket, square bracket, args. Okay. Take more advanced classes with me and we'll break down what a lot of that stuff means. Now, this is where the main body of the program is going to be. So as you can see, I'm going to put the main body inside of its braces. Now, there's going to be other blocks of code I can start to add at line 16 later. That's chapter 6. But for now, I'm going to do all of my work inside of the lines 9 to 15. In fact, I'm even going to put some documentation here. Again, I made it turn orange. And I'm going to say end of main, because we'll call this the main work area. So this is going to be our main. Yes, feel pretty good. I'm going to save it. A lot of you know the shortcut icon to save is that old-fashioned looking disk. And I'm now going to check for syntax errors. The way I do that is the shortcut is this little green plus sign at the top. When I click on this, this is going to do what I mentioned earlier. It's going to compile it, and it's going to save a new file, introdemo.class. Okay, when you upload again, I don't need the .class files. So I'm going to compile it. Down in the bottom, you see a big block. That block is called my console. And down in the bottom, I look and I see JGrasp operation complete. Whoop, whoop. That means it compiled and created bytecode. So that means now if I went up and in order to run it, right beside the green plus, there's a little red running man. And if I click on him, my program should run. I don't have it doing anything, but it ran. So I compiled it and I ran it. Okay, so what do we want to do? Inside of here, we can start working on displaying some things. For example, system dot, hello, where are we at? Here we go. I'm going to type system dot out dot println. Okay, system dot println. And what do I want to print? Well, I want to print out an exact statement. So when I do that, I want to create something called a string literal. Hi, mom. You notice it's green. When I put the double quotes, it starts the green. When I put the double quotes again, it ends green. At the end of lines of code, not what we put up there in line 5 or line 8, but at the end of line codes, we're going to need semicolons. So when it compiles, it knows it reached the end of that line. I'm going to compile it. Whoop, whoop. Hopefully I don't have any errors. Hopefully y'all don't have any errors. I'm now going to run it. And down there below, it prints out, hi, mom. Now, this is the console window, and the author uses the console window a lot. It's for programmers. When I would create a program for a user, though, this is where I'm going to use those things called GUIs. So I'll be using a different way to display other than system.out.println. Okay, that's saying, hey, I just want to go to the console down below, make sure things are working. All right, what if I do this? Change that capital S to a lowercase s, and I want to compile it. Well, this is another big reason why you're doing the code listings, because you're going to start typing things over and over. It's muscle memory. Doing push-ups doesn't seem like much, but it gets you ready for the football game kind of idea. So I type it in wrong, and I go to compile and say, whoa, yeah, let's see. I got an error. It says system does not exist. Oh, that's because everything in this language is case sensitive. It's case sensitive. All right. So I'm going to go down and I'm going to type in another line. You notice I indented consistently. So far, so good. But this time I'm not going to put the ln in. I'm going to do hi, dad. And when I run it, I don't have to compile and then run. When I click run, it'll compile it for me. So when I do that, I go down to my output and I see, hi, mom. Okay. I go to the next line. Hi, dad. Well, I'm going to put another line in here. System.out.println. And this time I'm going to do double quotes again. Programming is great fun. Just a side note, folks. If I'm going too fast, say, whoa, slow down. Hold on a second. Wait for me kind of idea.
I have a
But what
question.
happens when you don't put the ln?
Let's see. I'm going to run it here. And I know that it's hi, mom. And I have an ln. The ln is actually a carriage return. It says at the end of hi, mom, go to the next line. When I don't put the ln in and I say hi, dad, that means after it does hi, dad, it stays on that same line. So when I then put in programming is great fun, you notice how it's still in the same line as hi, dad.
So if you put the ln in print, it automatically moves to the next line.
At the end, yep. So now that I put it there, when I run this, after hi, dad, it should move to the next line. And there it was. Okay, I can come down here if I want. I can grab this bar and move it up so I can see more of my console if I so choose. Or I can move it back down, adjust it however I want it. All right. On page 37 in the book, it talks about escape sequence characters. And what an escape sequence character is this single backslash. Okay, so if I wanted to put in an escape character, I could do a single backslash and a T. Well, that's not a T, a T. The T stands for tab. So if I now run this, we're going to see where programming is great fun tabs over a certain amount of spaces.
So like it's like spacing the line.
Yes, it'll indent it. I could actually put in, if I really wanted to, /T, I could put in 3 /Ts. So these escape sequence characters tell the computer that I want to do a certain thing, and in this case, tab in. And if you look at this, it now tabs in, looks like 9 characters probably. What if I came up here to the end of hi mom and I wanted to put in a slash? This time I'm going to put in a /n. I'll put 2 of them in. If you do that and put them in, what does /n do?
New line.
Yeah, it's N for new line. So when I run this, so not only at the end of hi mom do I have a carriage return, I added 2 more to get hi dad spaced down a little bit lower. So when we're displaying things in the console window, we can use all these escape sequence characters. As I mentioned, they're in the book, they're in chapter 2, they're on page 37. What you got for questions so far, folks? Anything? All right, good.
I think I'm good.
All right, moving on. 1, 2, 3.
Wait, I have a question.
Go ahead.
I noticed during the code listing that we had, we put the print before println. Is it because there's only one line, or like, is there a time where you put the print in the first line?
You can put print whenever you want. You know, I could have made all of these prints and use /ns whenever I wanted to carriage return. So it's going to depend on how you want to display the output.
So you can either do println or /n.
Right. Yep. So if I got rid of this ln, you know, I'm still going to get a return and then another return. So there'll be a blank line in my output. So I'm going to say print hi mom, and then it returns once. That's the first /n. Then it returns again, which makes a blank line and gets it ready for me to do hi dad. 99% of the time, you're going to use system.out.println just so you can display stuff in the console while you're learning to write the code. And again, when we're done, we're going to eventually use GUIs to be able to display it for the user. Okay, so that's nice. That's, you know, I'm going to even come in here and I'm going to do something like this. I'm going to call this my output section because that's where I'm doing all of my output. Again, that's those slashes. I'm making notes for myself. I can put in there whatever I want. Now, in the world of programming, we have to be able to store values. And when I say values, I mean numbers, I mean characters, I mean words. There are so many different things we can store. So what I need are places to store it. In your world of math, you've learned of 2 things, X and Y, which I disagree with. you know, if I said to you, y equals 30x plus 40, you just turned off. You're like, I don't care what 30x plus 40 means. Well, first of all, I'd like it to be y equals 40 plus 30x. Instead of y equals mx plus b, I'd rather see y equals b plus mx. So if I, you know, in my world, instead of y equals 30x plus 40, I'm saying I'd rather it be y equals 40 plus 30x, because 40 is where you start and you add 30 each time. In fact, I'd still rather see cost equals 40 plus 30 times hours. Okay? Because if I said cost equals 40 plus 30 times hours, right away I'd say, tell me something about it. Well, if the plumber comes and works 2 hours, it's going to be $100. You know, the hours is the number of hours worked, and the cost is what's calculated, and it's all good. Well, this is what we're going to start to do in our programming world. We're not going to use things like y equals 30 plus x plus 40, because that's boring. And not only that, even though in my world, I'd rather it be y equals b plus mx, we're not going to use that. But we're going to start using things that look like what you see up above. Okay, we're going to give descriptive names. All right, so I'm starting to think about coming up with these descriptive names, and I'm going to knock this out, and I'm going to call this my declaration section. And this is where I'm going to declare the variables I want to use. For example, hour. You know, we're the company that does the plumbing works by the hour. So what type of numbers would be stored in a name hour? Well, they work by the hour. It's going to be 1 hour, 2 hours, 3 hours. What type of numbers were these?
Whole
Integers.
numbers?
Integers, right? So in the programming world, there's a data type that's called int. And what I'm going to say here is I want to create a variable named hour. And hour is going to hold an integer value. Okay, so I'm going to make a couple of notes. Hour can hold an integer value. So hopefully back in 5th grade, you learned the counting numbers. Then you added 0 and learned the whole numbers. Then you took the whole numbers and their opposites, and you had the counting number, or the integers. Then you added decimals and so on. All right, so I'm going to declare int hour. That means in my program, I can do something like give hour a value. Okay? And I want you to think of it this way. Hour is going to get a value. It's going to be assigned a value. The equals is called the assignment operator. Notes, equals is called the assignment operator. When I do my assignment, the left side is what gets the value. The right side is where all the work is done. For example, I might want to give hour the value of 40. Okay, so this is this is where I have some work going on. This is my what I'm going to call processing section for right now. Okay, I said hour gets the value of 40. All right, so well, let's see. I'm going to come down here and I'm going to add a new line. System.out.println. And I'm going to create my string literal. Hours equals. Now, in order to find out the hours, I'm going to put plus, because I'm going to do what's called concatenation. I'm going to make a big string. I'm going to say plus. Now I want the variable hour. So I don't put it in double quotes. I just do hour. Parentheses, end it with a semicolon. I'm going to compile and run it. And I'm going to go, woohoo, there it is. Hours equals 40. Okay. Now, the int data type is one of my what's called primitive data types. And we're going to take a look here at 4 different primitive data types. So an int is short for integer. You notice it's purple. It's a reserved word. Int is one of my first 4 data types. And then we're going to go into a little more depth with these eventually. Okay. My next data type I'm going to create something called a double. And a double is one that's going to allow me to hold any real number. So when I say real numbers, what's that bring into play? 7-letter words.
Decimals.
Decimals, right? So I'm going to be able to now store decimals. So I'm going to create a variable now, and I'm going to call it money. I'm going to do this. I'm going to call it my money. All right. So I would have a problem here. When I create variable names, there are some standards. And the standards are the first letter has to be uppercase or lowercase. After that, you can use uppercase, lowercase, numbers, underscores. But you can't get all crazy and fancy using special characters and so on. So if I'm going to create a variable called my money, I'm going to do like I did up in the title of the program. I'm going to do it with this, what's this called again? When I start the first word with lowercase and then every word after that I do uppercase. Has a name, a style name.
Camel case.
Camel case. Very good. Thank you. Camel case. So all right, I'm going to go here and I'm going to make some notes to myself, some more notes. My money can hold a decimal, comma, space, the camel case. Camel case. Okay, so I did that with something called camel case. In fact, I'm going to go up to here, and this declaration section contains the 4 primitive data types. Just making a bunch of notes for today as I'm typing, have some things going on. So that means down here in the processing section, my money can hold a value like to $1 billion because I won the lottery. Well, I didn't win that, or, kind of probably wouldn't be sitting here right now. I'd be crapping my pants. So I'm going to say my money gets 1,234.56. One of the things about using this double to hold all of my real numbers, the numbers with decimals in, I can't include commas. So I don't need to make a note, but I'm going to put one in here. No commas for you. No commas for you. Like the soup Nazi, right? No soup for you. No commas for you. Let's see how it looks if I print it out. System.out.println. My money is, and I'm just going to do something like that. And again, I want to concatenate, so I want to build this long thing. Had the string literal. Now, money ain't for nothing. And eventually we'll learn ways to format this, make it look nice. Put, I'm going to do this. My money is $ plus my money. I think Rihanna has a song, something about my money. Somebody better have my money. And oh, look, there it is. My money. My money. Two more data types, two more primitive data types that we're going to work with. The next one is called a char, okay? And a char can hold a single character. So I need a variable name to hold a char. I'm just going to go something short, sweet, and simple and call it CH, okay? And I do want to make a note on this one as well. I'm making a lot of notes this first time. A char has to be a single character in single quotes. Single character, single quotes. So if I'm going to come down here, I'm going to say CH gets the value of single quotes. Give me a character.
Z.
Z. How about a lowercase z? Ah, that's interesting. It did change it to a color as well. Z. It holds a single character. I'm going to come down here and display this. System.out.println. Double quote. My favorite character is plus CH. And that's going to help me to display that character. So a Z should come up. This could also be a character. Instead of Z, a 9. That's different than the integer 9. That doesn't have value. That's just the shape of that image, right? That number 9. That's what it is. So, you know, it can be the lowercase z. It could be just about anything you want to put on that you can hit from the keyboard kind of deal. And finally, I have a fourth primitive data type. In the world of computer science, I mentioned to you, it all goes back to binary, zeros and ones, okay? Well, along with zeros and ones, this has become what's called Boolean. Okay, and you notice I typed the word Boolean and it went purple. Boolean is going to be a primitive data type. You won't use it for a couple chapters and then it's going to come into play. Some of you understand Boolean algebra, and that's truth tables, things you can do with truth tables and trues and false and so on and so on. So I need a variable that's a Boolean. I'm just going to call it flag for right now. And again, I've been making lots of notes. And I'm, oh, hey, is that, right there, holds either true or false. Well, I put a semicolon at the end of that line. I didn't really need to do that. So I have another variable that I want to give a value, flag. And I just said it holds the value of true or false. Now, you notice I didn't put it in double quotes. I didn't put it in single quotes. I just typed true. It turned it purple and it's all good. So I wonder what it's going to look like if I display it. System.out.println Boolean, and double quotes plus flag. And I run it. And I ran. Let's see. Here we go. And it actually printed out the word true. Cool beans. Cool beans. I'm going to save this just because that's what I do. And now I have a pretty good idea of what's going on in the first three-ish, almost the first 4 sections of chapter 2. We talked about displaying output, the system.out, how the prints work, the printlns work, the /ns worked. We talked about the 4 primitive data types. We saw how we assign them values. The equals is what's called the assignment operator. And then we learn how to display not only string literals, but variable literals.
Can we talk a little more about formatting if we're done with this content?
Let me stop
Or
recording.
should we end the